Hello everybody. So in today's lesson, I'm going to be showing you how to use special triangles to calculate the sides without having to use the calculator and without having to use the trigonometric functions. So there are two special cases that we're going to look at. So the first one is called the 45-45-90 triangle. And the reason it's called that is because it's a triangle that looks like this, where two of the angles are 45 degrees and then one of the angles is 90 degrees. Now, when this is the case, it's also going to be an isosceles triangle because if two angles are the same, two sides must be the same. So if I was to say that this was 1, then that side would also be 1. Now, if I was to use Pythagoras, I would be able to calculate that this side would be the square root of 2. So all I want you to take from this is that if you have a 45-45-90 triangle, the ratio of the sides is 1 to 1 to the square root of 2. Now if we look at case 2, this is what we call a 30-60-90 triangle. So as you can see, we have a triangle here where the angles are 30 degrees, 60 degrees, and 90 degrees. Now the short side is always opposite the short angle. So I'm going to call this side 1. Now, the great thing about this special triangle is if the short side is 1, the hypotenuse is always twice that, and the other side is always the square root of 3 multiplied by that. So the ratios are 1, 2, and square root of 3. So you're going to need to use these ratios when we do these two examples right down here. So let me go ahead and show you how to set this up. So let's look at example number 1 here. We have a 45-45-90 triangle, and we have sides with x and 6. So we want to be able to find this unknown side. Now, yes, you could use trigonometry, but I'm going to show you a faster way to do it using this 45-45-90 property, where you have 1, 1, and the square root of 2. So here's what you do. I'm going to draw that triangle that I had at the top there. So look like that. We have 45 degrees there, we got 45 degrees there, and 90 degrees there. And remember, these two sides are the same. So if I have that, I know that that's 1, and the hypotenuse must be the square root of 2. So I'm getting that information from up here. So because the angles of these sides are the same, that means that these triangles must be similar. So if I want to find x, I just need to write out a proportion. So x corresponds with this side over here. So therefore x corresponds with 1, or it's proportional to 1. The 6 corresponds to the square root of 2. The hypotenuse corresponds to the hypotenuse. So that's going to be 6 over the square root of 2. So basically, if you want to figure out x, all you have to do now is use cross multiplication to solve this equation. Well, in fact, x over 1 is just x, so my answer is just going to be 6 over the square root of 2. Now, when you do the delta math questions, or in fact, if you ever do any SAT questions, things like that, they never want a radical on the bottom. So to get around that, we do something called rationalizing the denominator, which means I multiply the top and the bottom by that denominator of the square root of 2. So what we get is 6 times the square root of 2 is just 6 square root 2. The square root of 2 times the square root of 2 is just 2. And then if I have a 6 on the top and a 2 on the bottom, 6 divided by 2 is 3. So my answer would be 3 square root 2. So basically, this unknown side here would be 3 square root 2. See, no trigonometry involved, no Pythagorean theorem involved. All right, let's have a look at another example. So this time, I've got a 30-60-90 triangle. And I'm told that this side is x, and this side is 2. And I want to find that x. So what I do is I draw a similar triangle using the properties from above. I know that this is 60 degrees, this is 30 degrees, and this is 90 degrees. And the ratio is always the same. The short side is 1, the hypotenuse is the square root of 2. The hypotenuse is 2, and the other side is the square root of 3. Because they all have each triangle has the same angles, I know they're similar. So I set up a proportion. Here's my x. So x and this side, these two sides are going to be proportional. So that means I have x over 1 equals, and then if I look, I got these two sides. I know that these two are going to be proportional too. So that's going to be 2 over the square root of 3. So x divided by 1 is just x. And then I have my answer as the 2 over the square root of 3. Now that is the right answer. But again, a lot of problems will always want you to rationalize the denominator, or in other words, have no radical on the bottom. So what I do is I just multiply the top and bottom by the square root of 3. And I'm not changing the fraction at all because I'm really multiplying it by 1, which doesn't change anything. So 2 multiplied by the square root of 3 is 2 square root of 3. Square root of 3 times the square root of 3 is just 3. There's nothing left to cancel here, so that would be my final answer. Now, you will have some difficulties along the way with this. It's a little weird at first to try and get your head around, but I would strongly suggest using the similar triangles approach because it does make things very uniform. So you're pretty much doing the same thing every single time. So reach out if you have any help. Oh, sorry, reach out if you need any help, and we'll be more than happy to do so. All right, thanks very much.